my goal is simple. I have this line, and I have curve view value also, which goes from 0 to 1, and I want to rotate uh, a loop, another curve onto this line. So if I see it from this view, my goal is simple. I have this out vector from this point. I want to rotate it by this, and for each point I want a different rotation. Like for each point I want the different rotation of this vector, so we can have this loop. This is my simple goal, and if I just create another with another color, so this is the vector and I have this vector. I just want to rotate it along this n axis, right? And if I open Houdini, you will see I have something like this. I have the curve view, and I will just say orient along curve. This will give you the up. We don't need up, we just need out and n. And if I say n and up, not up, out, this. And if I just visualize the out, you will see its unit length, its length scale is 1. Okay, I have something like this, and I don't need to see the n point attribute. I have this, right? And this is the vector, and I want to rotate this vector along this n vector. I have different methods. I have 3 methods. They are based on one same thing. We will use quaternion, and I will say point triangle, and inside this point triangle I'll just create some expression. So we know that we have curve view, and that curve view can act as the base to create some different rotations um, for each for this out vector and at each point. So my main goal here is the quaternion rotate. So I will just create the last thing that I want to do is q. I will say v attribute out will be q rotate, and I will say I want the quaternion, which will be rotation, and the axis will be n. So I need so I need this rotation quaternion. So I will say vector for I will say rotation, and it will be our quaternion, and I want the angle, right? And I want to have the axis of rotation will be out, and I want to have the rotation axis, which will be n. Now I need this angle of rotation, and this angle of rotation here can be calculated by different methods. So this is our final this is our final thing. This is our final code. So what we are doing, we are just extracting a quaternion, the rotational data for this vector, and I don't need to explain this. This is my TD notes, to be honest. So if you want to like view how these works, you can go to other videos and you can see where I explained these. So we need this angle, and if I say float, and I will say angle, and I will just say CHF angle and create this, you will see, and you will see now I have this rotation, right? But I want this angle for I will say fit and curve view, right? The curve view is going from 0 to 1, so I will put it here, and I want 0, and 6.285, right, which is 2 pi radians. And I will say attribute curve view here. So you see our rotation is happening uh, along this line, and what I can do, I can just say v attribute p equals to uh, plus equals v attribute out and multiply, let's say CHF. I can say, I don't need to, but I can say, let's say multi for now. And if I end this and create this, so you will see our code are this these points are now adding this out vector also to their position, and we are seeing this, right? And I don't need to do this. I can end my code here. So you will see we will have uh, the same thing here, right? And I don't need to do it right now, so I will just delete this. And you see I have rotated this vector along this line by this method, by just putting this 0. I just fitted the curve view attribute, and it was from 0 to 1, and now I'm saying it is from 0 to 6.285. But what if I don't want to like do this, and I will say curve u angle. So we can understand this, that we are seeing the rotation from this curve u angle, right? And I have this is my first method, which is the simplest method in this. But the second method, I will use modulo function. And by this modulo function, what I want to do is, if I have this curve, so and the curve u value goes from 0 to 1, I want the modulo value, and I will guide my angle by this modulo value. So if I'm saying I want the modulo value from 0 to whatever I want, like 0.2 or 0.5, like in between the curve, so I can normalize it and I can put this value up to here. And I will just do it, but I will do the like basic modulo function first. So I will say float m modulo angle, and we will guide this angle by m angle now, and this angle will be by our I can say this fit, and I can say fit, and I can say attribute curve view and modulo whatever I want. This I will just say I want the float, and I will say m, or I can say modulo angle will be CHF m angle, and I can just end this, and I will have something like this, and I can say modulo angle, and it is going from 0 to this modulo angle, and from I want this 0 to 6.285, right? And when I say m angle, you will see now we are getting this. But this is another method which I was doing wrong. This is where I got stuck, because you see what I was doing this, and we can guide this the 6.285 by creating another float parameter, and we can put it this value inside that, and or we can multiply this, so we can just say how many rotations we want. If I say here I want the curve u angle, And here if I say I want to multiply this by CHF or CHI, and I can say the C multi, right, to understand this. And if I create this, so you can say now we have one rotation, we have two, we have three, we have four, based on this 6.285. 6.285 means 2 pi rotation, that it is in radians. So if I multiply 2 pi by 2, so you will get two rotations. Then we have 4, we have 5, we have 6. You can do this. The third method to create this, you can, instead of putting this modulo angle here, you can first normalize this value, because here the modulo angle, if I'm putting here, I will just put here is m angle, and you see here this, if I'm saying 0.5, and if I open pure ref, that means I am at this. So my raw modulo value is going from 0 to this 0.5. 0.5 here means 1, right? That means we are getting 0, but the raw range is going from 0 to 0.5, and this is where I got stuck. I was thinking the raw modulo value was 0 to 1, but no. For example, if I am doing like something like 0.2, and I am here, so at 0.1 the remainder will be 0.1, but at 0.1999, 0.2, and 0.2, 0.2, you will get here 0, but here you will get 0.199999. So the max value will be 0.2. At this value it is converted back into zeros. So the range that I was yeah, I was getting wrong of this raw modulo value. I was thinking it was 0 to 1, but it was actually the same value that we are putting here. The like the same value that we are moduling our curve view attribute is the same maximum value here. What I was doing, I was creating, let's say, I will say this normalized value. So float, I will say n angle will be the normalized angle, and what I was doing, I was saying curve view divided by, I'll say modulo angle. Again, we can use the same slider for these two, and I was saying 0 1, and I was saying 0, and I can say 6.285, something like this. If I don't need to like so you see here, if I put here an angle, you will see the rotation is not being completed because the value is ending here, right? So this was the issue I were having, and I was like thinking, what should I do? Like, why is not, when I'm saying the modular value is not from 0 to 1, if I'm saying the m angle is 0.5, that means the modulo value here is not 1, it is from 0 to 1. So I'm converting this range. So what I'm doing now, so I have the modular range which is going from 0 to 0.5, and I'm converting this, into 0 to 6.2, 6.285. So this, right, that's why I was seeing something like that. So what do we need to do? We just need to normalize our this value, this row modulo value, so we can get our data right. And the modulo value here is this, right? So we need to normalize this modulo value first before we can write this expression. And to normalize this value, what I can create, I can first put this curve value curve view value into another float, then we can like play with that. So I will say attribute f attribute curve view will be, and I will say, or I can create another curve float curve view value, which will be attribute curve view. So I have something like this. This is just a curve view value. uh, what's wrong? F this. Okay, now we need to normalize this value, this range. Okay, so I can say f attribute curve view equals to f attribute curve view divided by uh, modulo angle. You will see uh, what is um, modulo. This is not. You see, it can be a bit confusing, but I guess we will be fine. I just need to normalize this. This is not like the modulo angle value, which is from 0 to 1. So I need to normalize what? I can say if I have this curve which is going from 0 to 1, and if I'm saying I have this value which is going from 0 to 0.2. So what is this value? This is the raw modulo value. Yes, so what I can do, I can just put the here, I can say this raw modulo value, right? This is the raw modulo value. So I can say I can put here is the curve view value, and I can say this is our angle, this will be our angle. So I can say curve u value, and here is curve u value, and I can put this curve u value divided by modulo angle. This will be our modulo raw modulo value. And if I say divide divide by modulo angle, maybe we will get our, yes, right. So when you increase or decrease this, you will get something like this, right? So I just normalize the value before feeding it into here, right? That's why now I'm getting the. So we have like three methods: putting the value first, or normalizing it, or directly using the curve view. And what if I want to like offset this? So what I can say, the curve view angle, I can create this float, offset, or I can say curve view value will be our, I can say offset or curve view. It will be like offset curve view, and will be say curve view dot value, curve view dash value, and I can just add something like chf offset and put it right there. And I will say here, instead of curve view value, I can say O, and it will be our curve view. So when you offset this, this is nice because we are offsetting it from this point, because here the m angle value is 0.5. I will say 1, and now you will see we will offsetting it, or m angle value will be 1.01, and I will offset it by there. So you see now we are offsetting the, the curve view value, the raw modulo value by this. So we are adding, so uh, we are moving the whole curve view value. If you say the value is 0 to 1, and when I said offset, when I'm adding this value, so this value which was 0, now it is 0.4, and this value is 1.48 1.418. So now we have offsetted the range successfully, but this is like not the way to offset this. So what you can do here, you can just to offset this, what you can do, offset, we can use the modulo value here also. It will be always from 0 to 1, right? The curve view, I can say plus, or I can say modulo chf offset. Now we are getting the same result, not offset. What I did, offset. Okay, not this one. You can just offset the whole curve view value. You can say attribute curve view plus equals the same thing, like we were offsetting the modulo value. You can offset this whole, you can offset the curve view value first before doing the modulo operations. So you will say chf and offset, right? And you can, like, you want to do it first, like you want to do this first. You want to do this offset first, because if I say the angle is this and you will offset, so this will offset from the same value that you have this angle. So you need to do it first. And when you say offset and I will say curve u value. Now when you offset this, you see it is offsetting, right? And how would you say it is offsetting? If you increase, it is resampling, so no need to worry. This is the whole offset value. You see, this is offsetting. If I create a curve, or let's say draw, right, and I say projection z explain, and I draw something like this, right, and if I go there, you will see I have this. And if I say if I say v attribute p, I'm just adding the v attribute out, right? That's it. So you will see something like this. They're getting outside, but this is not what I want. Draw curve. If I can just draw this curve, not this, so I will just draw something like this, so it is easier for us to understand this. And I will just increase the decrease the M angle so we can have more rotations. And you see now we are doing something like this, and when I offset this, you see it is offsetting, uh, like successfully without any issues, right? And so the main purpose to create this video was to understand. I just wanted to debug this situation, which I did. So the range of your raw modular values will go from whatever your modular value is, whatever uh, the value that you are dividing your curve u value or another value with this modular value. So you need to understand that the raw value will be always not greater than the value that you are calculating the modulo from. So that's the note that I wanted to take, and this is it for this video. I've successfully created this, and maybe when I create the uh, for each loop, then we can do this operations but with different iterations, and then we can understand it more.